Here at the Buncombe County Landfill, we're standing on top of garbage that's been in place since 1997 when the facility opened. We've been here since then disposing of Buncombe County's garbage and recycling all those recyclables. It's a 557-acre site. We've got a construction and demolition landfill. We just completed an expansion for that where we're going to add 30 more years of construction and demolition landfill space, which significantly helps save space in our line landfill, which is where all the bag garbage from your house goes. So that's a big help for us. Behind me you see the generator, which is our landfill gas to energy facility. So not only are we managing your garbage in a responsible way and handling all those recyclables, we also have a lot of really great projects that we do out here. We've got the gas to energy project, which you've heard a lot about, where we're generating electricity, about enough for 1,100 homes right now. We hope to triple that capacity by the time the end of the landfill comes around. So in another 20, 30 years, we hope to have 2 more of those generators. So we'd be putting out that much extra power. And part of what feeds that power is the other project we've got, the bioreactor project that's through the United States Environmental Protection Agency through their Project Excel, which is Excellence in Leadership. And that's where we're recirculating leachate into the landfill, feeding the bugs and speeding up decomposition. We have a lot of goals for that project, and we're constantly checking on the progress of that project, see how we're meeting those goals. We had the major milestone here this summer with our new lines that went in and some temperature probes, which I'll talk about later with you. So we have a lot going on out here, and we're excited to tell you about it.
Hello, I'm Danny Biddix. I'm a big equipment operator for the Buncombe County Solid Waste Facility down in Alexandria, North Carolina. My job is to push the trash that comes in and pack it. The machine I run is a T-Rex, a trash master, which pushes the trash and packs it. Been here about 8 years. Have been running the trash master for the past 4.5 years. The reason compaction is so important in landfill, the tighter it's packed, the less airspace you use, and the more space you have for trash, which makes the longevity of the landfill a lot longer. So compaction is one of the most important things. Then we cover it with dirt so to keep the odors and the rodents and stuff like that out of it. Every day we have a posi shield that we had to spray on top of what we don't cover with dirt. And that way it keeps the blowing down. And then if you notice the big catch fences around here, we have catch fences to what little of the trash does blow, that it will catch it and confine it in the landfill here. We have about 500 tons of refuse come in every day that we have to spread and cover and everything. And this area here is area number 1, which is it's a line landfill, which in other words, we have another area that's C&D area that it's more for, like I said, construction and stuff that you don't worry about getting any water systems. We're lined landfill. It confines everything within the area. Then we pump the leachate water out to a holding pond, and then we pump it back into the cover of the landfill to make it rot faster. And when it deteriorates faster and everything, it puts off more methane gas, and we have a generator here that runs off the methane gas that we produce electricity.
My name is Aaron McKenzie. I'm the power plant operator at the Buncombe County Landfill for the Solid Waste Department. My job as a power plant operator is to keep the generator running and to balance and optimize the landfill gas well field, and also to keep up with the data collection for the carbon credits. We're sitting right here today in front of the SCADA system. We've got two computers here. This one over here, it collects the data from the generator and the blower skid, and this one over here records the data. This is basically just a schematic overview of some of the major systems. It's running at 1427 kilowatts, so that's 1.4 megawatts. The computer actually will not let you turn it up any higher than that. This spreadsheet here, like every day, it'll, at 15-minute intervals, it'll record the total gas flow, the individual cylinder temperatures, to make sure that it's above 500 degrees Fahrenheit, because they want to make sure the methane's destroyed. So there's 20 cylinders in the generator, and each one of those is the temperature's logged every 15 minutes, 24/7. Now we're going to walk around and do our daily log. This is basically where I go around and read the instruments and just check out the machine, see where it's running. We saw earlier the digital readouts, but it's always good to come physically look at the machine just to make sure nothing's obviously wrong. What we have here, the gas comes in to the plant through the uppermost stainless tubing into what's commonly referred to as a gas conditioning system. This one's fairly simple. It just compresses the gas up to 5 pounds, and it has an air cooler to cool it down to about 85 degrees. The landfill gas, depending on ambient temperature, can be anywhere between 100 to 60 degrees coming in, just depending on the time of year. And what this machine does, it stabilizes the temperature around 85 degrees, filter out some of the larger particles so they don't reach the engine. And it also has a lot of monitoring, such as flow, methane quality, temperature, pressure. And we'll go over here, and over here it goes into the generator. It's just a stationary 20-cylinder engine with a generator on the back. It's kind of similar to a railway locomotive. It's just it just sits there and it just runs the generator. It's a 480 volt generator that goes over to the transformer there, and the electricity is increased to 13,000 volts and fed back into the grid. And so I'm going to be walking around the blower skid and taking readings off of that, and then we'll go into the generator and check a few gauges in there, make sure there's oil in it, and we'll take some further readings off the computer in there. Usually, on a typical day, after I've inspected the generator and everything appears to be fine, I'll go sample some gas wells. I need to make a minimum of 2 complete trips a month around there, hopefully more. The more I look at them, the better. The better the gas going to the generator, the better it runs, so it's one of those things. The more I do it, the better. I want to talk for a moment about a leachate recirculation landfill. The first thing we had, I was up on the landfill and I was actually opening up vertical and horizontal wells. They are very similar to wells you might use for normal groundwater. It's just a slotted pipe. They're laid within the garbage, and the purpose is to wet the garbage to increase decomposition of the trash, help aid the anaerobic bacteria that produce the methane, and encourage settlement of the mass. And it's hoped by aiding the bacteria to have more methane production for the generator. And if you can increase the rate of settlement, that'll aid in possibly creating more room for garbage in the future. Down there where we saw the leachate pond, that's where all the leachate comes from the landfill. It's the liquid never leaves the liner. It doesn't go into groundwater anyhow. There's like several compacted clay, like a 60 mil poly plastic sheet, if you will, and then the mass is above it. And these pumps are within the mass, and they take the leachate, pump it out into that pond. And as you can see into those pictures, there were 2 large HDP pipes going into the pond. There are a couple pumps there. Each pump can pump about normally 250 gallons a minute into those wells that we'd opened up earlier. And the idea is we recirculate the leachate. It keeps the landfill happy, and we cut down on costs for having to truck the leachate out in tankers. Obviously, when you have a big mound of garbage, there's no oxygen inside. And in that anaerobic environment without oxygen, there's certain bacteria that grow, and one of the byproducts is hydrocarbons, such as methane, which is CH4, and they also give off nitrogen. The methane that we're pulling out is what we're running the generator off of, and it's very important not to introduce oxygen into the system or oxygen into the landfill, because then you'll kill these anaerobic bacteria. They just don't exist in the presence of oxygen. In the wintertime, we generally don't recirculate the leachate because the anaerobic bacteria like warmth. A lot of times the gas temperature is around 90 to 100 degrees, and if we were to inject leachate water below 50 degrees, we've kind of used our benchmark, we would possibly kill the bacteria, and that would have a detrimental effect on the methane production, and obviously the bugs wouldn't eat as much garbage and stuff. So during the winter time, we don't circulate leachate. We'll just we've got a couple tankers, and we'll take it down to the MSD where they treat it there.
So essentially what I'm doing today is sampling the leachate out of every cell for our bioreactor Project XL US EPA program. The US EPA XL program stands for Excellence in Leadership. So we're helping collect data and analyze data for the EPA for some federal rule changes that are possible down the road. So what I'm doing today is essentially part of the agreement we made with them back in 2003, where we sample leachate, kind of tell how the garbage is decomposing, how everything's working with leachate recirculation. This allows us to see if leachate recirculation is impacting the landfill garbage and decomposition process. Sometimes putting that same water back in over and over and over can spike certain things like ammonia that aren't ideal for the bugs living in the landfill. So we're basically watching this stuff all the time to make sure that we're not impacting those bugs so that we can generate the gas for our gas to energy project. So I've got different types of bottles for different types of monitoring that we do for the Project XL program. We do BOD 5, which is biological oxygen demand. We do COD, which is chemical oxygen demand. We do pH, ammonia, and specific conductance. And all those parameters were picked with our stakeholders that are in the university research sector that kind of help design the monitoring program so that we could track decomposition over time. So that's what all these sample bottles are for, and then all these will get filled up today with all the different cells and the leachate pond. So there's 6 active cells and the leachate pond, so there'll be 7 of these bottles filled today. So I'm going to go ahead and label these, and we'll get started sampling here at cell 5. So essentially what I'm doing here is at cell 5, I'm starting here. You'll see me get into our sample box. It's a vault box where I can pull leachate out of the very bottom of the landfill. This one is about 100-something feet down. You can turn the pump on that's at the very bottom. It pumps it up and out into the leachate pond. But I've got this vault box that allows me to pull a sample up on the surface. So what I'm about to do is take my readings for what that pump is, turn it on, and then we can collect a sample. All the data that gets collected in the field, I bring back to the office and input into our spreadsheets. The lab data we get back from the lab goes into these spreadsheets, and these goes all the way back to 2007. So we've got years and years and years worth of data that we've been tracking. We also have a website, the Buncombe bioreactor website, that all of the data is uploaded to, so that North Carolina Department of the Environment and Natural Resources, DENR, and EPA can review it. We have photographs of work that's going on. What I showed you up on the hill, the new lines that went in, we highlight those, how they got constructed, how we're going to use them, how we expect for them to perform. It's a timely process to analyze years and years and years worth of data. So this is kind of an example. It goes all the way back to '07, where we're able to track how that leachate and that environment within the landfill is performing over time. We're able to monitor the environment inside the landfill. We're able to see how quickly garbage is decomposing. If we're injecting leachate into a certain area and we see a spike of something, we know that we will inject into a different trench and let that one settle out for a while. And then if we see our gas production is doing really well in a certain section, that helps us know that the leachate's doing a good job there. And then if we have another section that maybe is an underperformer, we'll know to try to inject a little more leachate there to kind of feed those bugs and keep that environment going. Adding leachate definitely speeds up the process of decomposition, which ultimately means you get more gas to produce more power. So that's ultimately what we're after. That, and we're not having to haul trucks down Riverside Drive to MSD to get rid of leachate. We're able to treat it on site, recycle it back through the garbage, and handle it that way. We're standing here on the second phase of the bioreactor project. This is the phase 2 build as you go, which is a huge milestone for Buncombe County. For the bioreactor project, we've been waiting for a while for our garbage in cell 6 to be at an elevation where we can lay some new leachate injection lines. And that's where we're standing now, is the new injection lines. So these are our new valves. This is how you put the leachate into the landfill. This is how you extract the gas out. So if you want to pull the gas out, you'd open this valve and send it to our gas-to-energy facility to produce some more power. If you want to inject some liquids, you can open this valve. And once you open this valve, it sends the leachate from the leachate pond up this hill and into these trenches. And all these trenches are buried in garbage. They've got about 20 to 40 feet of garbage below them. And we've got 5 trenches where we can inject leachate. So this is an exciting thing for us, where we've got new injection lines. They're in at a lower elevation than the old lines, so they're actually closer to the bottom of the landfill, and we're going to keep building them up as we go. So when we go another 30 feet up, we'll lay another set of lines in, and at that point we can extract a lot of gas off of those and then strictly put leachate in on these bottom tiers. And another component of these new lines is we put the temperature probes in, which you just saw the screen, where we're able to track the temperatures. And what we hope to do with those is, when we turn the leachate on into certain trenches, we're going to watch those temperature probes real carefully. And we'll be able to see if that leachate is reaching that temperature probe, and we'll be able to tell, based on which trench we're ejecting, how far that leachate's able to travel through the garbage, which is a big question out there. Nobody truly knows how far that leachate can distribute into that garbage. And it will also be able to tell us in the wintertime if we can recirculate in the winter. Right now, if leachate gets below 50 degrees, we stop recirculating, so that the environment in the landfill is still conducive to those bugs to generate that gas. But ideally, we can recirculate during the winter, get rid of more leachate, keep feeding those bugs, give them a constant environment. So these temperature probes will help us determine if cold leachate in there is impacting that environment or not.
Today is household hazardous waste collection. We do it every Friday from 9 o'clock to 3 o'clock. Basically what we do is, the main purpose of the HHW program is to separate the hazardous chemicals, the toxic leaching properties out of waste that could be harmful to the environment or to the groundwater. We try to keep that out of the landfill. Basically, we've got several different stations. Where I'm standing now is the chemical composition area. We do pH, and we basically look at what the chemical is. We're not set up to take anything other than household waste, household hazardous waste, household chemicals, things like that. So basically we're looking at the containers, looking to see if it's something that, you know, would come from a household. And basically we're diagnosing the properties of it, and up front you can see this is a combustible chemical marine formula. So we know right away, you know, we can start there as far as the hazard class goes on it. And we look to see if there's any other hazards that would be of concern. And the next thing we want to do is take a pH to make sure that it's consistent with what the container shows, because, you know, a lot of times people may switch containers out, put a different type of chemical in there, so that's one thing we have to watch for. And that there is pH in clear, which looks to be a hydrocarbon, petroleum distillate, something of that manner. Looks like a multi-purpose cleaner, non-abrasive, biodegradable, so right away you know it's probably not going to be something that's going to be all that dangerous or potent. Looks like just a standard household type of chemical. We'll take a pH on it, and the pH is looking, it's coming out around the 8 or 9 area, so a little more on the base side of neutral. So we would go ahead and label that as such. We have a 3-bay explosion-proof building over there that we separate these chemicals. There's a flammable room, there's a alkaline/oxidizer room, and there's also an acid-based room. So that's where we separate here. When we're separating the chemicals, put them on the cart and take them to the appropriate area to where we can store them properly. It's in a contained area with secondary containment as well, and we know it's going to be safe in there until it comes time for us. You know, once the containers are full, whatever we're packing, and we can get those ready to ship out to our Vendor 3RC, which goes through the recycling process. We're all trained up here to do different things, so whatever duty calls for, you know, if we need to be over here pouring up paint like Nancy's doing, or working electronics, or separating chemicals, you know, most everybody can work these areas, so that's helpful. When TVs are crushed and the components are broken down in an area and water leaches through those components, they've done tests with the toxicity leaching procedure, and it's basically how it breaks down, and when it's crushed up and water actually leaches through those electrical components, it leaches down toxic properties. And of course we have a lined landfill, but still, as a safety thing, and to keep as much of those hazardous and harmful materials out of the landfill areas is our goal, to separate those, and we also send them down to be recycled. So, you know, that's been saving airspace, but it's also, we're trying to prevent those toxic properties from entering the landfill.
This is a typical Friday at the landfill. We're in household hazardous waste at our light bulb collection recycling area. This table is where we process the light bulbs from the residential customers that come in. This is a typical load we get from somebody's car. You've got your fluorescent light from somewhere in the house. You've got all these little fluorescent lights that go in your lamps and in your bathroom. So we recycle all these, and all these get wrapped up and boxed. They have to get counted for DOT shipping standards. And then we have a barrel over here, and that's where the 4-foot tubes go that get recycled from your garage, your kitchen, that type of place. And there's green tipped lights you saw in there. Those are less mercury containing lights than the non-green tipped ones. So if you ever want to buy the less mercury, that's the best one to buy. We want to keep the mercury out of the landfill, out of the groundwater, out of the environment. So when we process them here, they get recycled. They don't have to bring it all the way out here. We have a program for fire departments. There's 12 fire departments throughout the county. You can bring your light bulbs. There is a size limit. They don't have a whole lot of room, so it's mostly just for these small CFLs and a couple tubes, just from your house. You know, a couple lights at a time is what you can take out there. On our website, you'll see all the 12 fire departments. They're scattered in all cardinal directions of the county, so hopefully you can find one close to your house. Home Depot and Lowe's have drop boxes in the front of the buildings, so if you go in and you have some light bulbs, you can drop them into their little recycling bin, so that you don't have to worry about going to the fire department either. I believe mostly what they take are these type. They don't take the big 8-footers that you see over here. And I think Lowe's may have the 4-foot box, I'm not sure, but that's another place you can try to recycle them. typical day at the landfill is not really ever a typical day. You never know what's going to happen. We're always got customers coming in with recyclables, with garbage. We have a household hazardous waste day. Getting out in the field, checking some of our sediment detention ponds for myself. Those get checked weekly for the Division of Water Quality with the state regulators. We also have erosion permits that are active for some of our construction projects go on, so getting around and checking on those and make sure the erosion control is in place is a typical daily activity. Checking on all the leachate pumps, making sure they're operational, usually daily, especially after a lot of rain. Recirculating leachate on any given day is another common practice. And then some of the work I've shown you today is something that happens about every 3 months where we compile all the data. And then on a daily basis in the afternoon when I have a couple extra hours, I can go back and analyze a lot of that data and start making those graphs and entering all that into the spreadsheets and getting ready for the next progress report that we'll send out to the EPA.